Hello guys, welcome back to this advanced level combined mathematics YouTube platform or advanced mathematics for any type of maths, future exams, applied maths, pure maths, Edexcel, Cambridge or higher mathematics, further maths or typical problem solving through this video series or expected future exam problem. Okay, please subscribe the newcomers and share this for take full advantage of this video series. Okay, see a nice integration problem today. A nice workout. Square root x minus 1. Square root x minus 1 over x cube minus 3x square plus 3x. Integrate respect to x. The boundary is from 2 to third root of 3 plus 1. The boundary is something. See this how this. Third root of 3 plus 1. Okay. We'll see later part. I think the answer showed that some pi by 6 or pi by 18. As pi by 18, you have to work out. It's completely equal to pi by 18. Show that problem, right? Okay, nice work. Oh, see my method. So my method, but the answer is given. You have to derive this expression, right? Now see, this is x minus 1 part. That is x minus 1. Therefore, I try to show the denominator also in terms of x minus 1. X minus 1. See what happened if I mark cube. X minus 1 cube. X cube, right? A minus B binomial expansion. X cube minus multiple both 3x square, yes, plus 3x minus 1 cube, right? If you expand, you know, there are 4 parts. A minus B cube, A cube minus 3A square B plus 3AB square minus B cube. In that format, if you expand this, everything okay. Finally, minus 1. There's no negative 1. Therefore, to remove, I can write plus 1. Okay. This is the dx. The boundary is from 2 to third root of 3 plus 1, right? Okay, nice. Now, see, I will show one substitute format. I will take now that square root x minus 1. I use that square root x minus 1 as t or u. I will use some one of the most suitable transformation or substitute this problem. I take let can I take t equal t or u whatever square root x minus 1, right? So if you work many problem in integration or limits whatever, if you use the substitute y, the problem becomes easier, right? Problem becomes a simple format. That's why we use this kind of substitute. Also in integration, especially after use of this differentiation dx, you can see some parts available in this question. In this integration, some part of this format available. That means, you know, we have to change all the parts to the t format. So very first, what is dx? Differentiate this, differentiate respect to x, dt over dx, okay? Differentiate the square root differentiation 1 over 2 times square root, okay? Square root differentiation 1 over 2 times square root, and the inside inner function x differentiation 1. Everything okay, right? Therefore, otherwise, I can write this 1 over 2, but it is x minus 1 square root. That is my t, right? Okay, substitute. So I can write dx square root of x minus 1. Now we change, complete the problem into the t term. Also, we can change the boundaries. I'll come last to show that part, right? Therefore, see furthermore, I equals square root or square root x minus 1 t, right? T, okay, over what is x minus 1 cube? X minus 1, we write the dx also. See what is dx? We cross multiple 2t dt, right? 2t dt for what that cross multiple 2t dt is for dx for 2t dt, right? And see, what about this x minus 1 cube? So if you come this, note everything clearly. X minus 1 I use as square root completely t. Otherwise, if I square it, square it, no square root t square, right? T square is x minus 1. Wow. This is therefore, what is that? T square, right? This is t square power 6. So t to the power 6, okay? T to the power 6 plus 1, right? So the problem becomes a wow problem. See, I equal integral. I can take the 2 out, but that t square over t to the power 6 plus 1, right? Completely integrate respect to t, not time, t, right? Now see, actually we use the complicated hard problem, hard expression to get a simple format. I use some integration substitute. If I come once again, this is another hard, typical difficult type of expression. So here I use another substitute. That's the technique of this problem solving. Not only one substitute, I can use another one also. Accordingly, boundaries also changing. I will apply later. So here, see what the most suitable substitute I can use to make another familiar integration part. See, for this, can I take let t cube something? T cube is u equal, because tan inverse, what is tan inverse format? 1 over x square plus y, a square plus x square. Okay, 1 over a square plus x square, tan inverse x over some that pattern, right? Therefore, see, can I take now, let u equal t cube, u equal t cube, right? Now another person comes as u, another integration substitute. Therefore, now I change all these entire problem into u terms. So what is du over dt, right? What is the answer? 3t square. Okay, 3t square. Wow, yes, come that back. I equal integral. Oh, what is that? Dt t square. Dt t square. T square dt is du over 3. Is it? Check, nice. Du over 3 is a t square dt, right? Now t power 6, t cube is this. Therefore, both sides, if you square it, wow, see what a superb workout, very useful. Straightforward book theory, your theory class of trigonometric or the something integration, parts of standard integrals, right? So therefore, integral, we have the limit. We'll see step by step that one. Yeah, I can do the answer. I think this 2/3. Okay, 2/3. What is tan inverse u? Is it tan inverse u? Okay, plus we have the c. But these are definite integration, no arbitrary constant, right? Therefore, the answer 2/3 tan inverse u. If I come back to apply this answer in the previous cases, so we have the previous case. If you answer this I use this I, later part becomes t. Okay, so I said number 1. Okay, now take this answer in the number 1, put it the number 1. This I, the once again there is I. So this answer becomes a 2/3 tan inverse u, right? But you know what is u. Okay, come back, see how I'm explaining the substitute. Now almost finished. 90% problem is over. Now very important, how to use the boundaries. Okay, study how to use the boundary part here. Erase this. Show here. Come back now. in the first equation, right? The first integral answer, I equal, okay, check that. Is it okay? This 2, right? 2/3 complete according to this 2 there, right? 2/3 is okay. 2/3. Okay, 2/3 integral this answer 2/3, that is 2/3 tan inverse u, right? That is 2/3 tan inverse u, okay? Tan inverse u, tan inverse u, okay? So I equal 2/3, come back, what is tan inverse u for what? What is u for t cube, right? U for t cube, okay? This is the answer, plus we have the arbitrary c, but letter part c cancel, right? Now finally apply this boundary. We use x minus 1 as square root t. So I equal 2/3 tan inverse t cube, right? 2/3 tan inverse t cube. That is, this expression becomes I equal, that is I, later part I becomes that. Now you know what is t. Now apply for t now. See, once again, nice work. Reggie, see a fantastic expression in integration. So finally, again, you can write properly 2/3 on tan inverse, okay, tan inverse. What is t cube? What is t? You know t, you know the t answer. So its cube means both side cube it. So square root x minus 1 cube, okay. This is the part. I can write this is actually x minus 1 power 3 over 2, right? Can I write that one? I equal 2/3 tan inverse x minus 1 square root power half, that is 3/2, right? I neglect the arbitrary c because this is in definite integration. Okay, now from here we can apply the proper substitutes for this definite integration, lower limit, upper limit. Now see my method completely lower limit 2, upper limit 3 root 3 plus 1, right? See how this when you apply upper boundary minus lower boundary for x value, the answer show that pi by 18, right? So I equal 2/3, okay, come to the upper boundary, tan inverse, right? Tan inverse. So x4 3 root 3 plus 1 minus 1, so cancel 3 root 3 power 3 over 2, right? Minus lower boundary, put x4 2 here, 2 minus 1 is 1. Wow, tan inverse 1, right? Okay, so finally the famous question we can expect one day. This is one of the pure mathematics question in any type of exam papers. 2/3 come back tan inverse. So you know completely 3 root 3 and 3. What is 3 and root 3 means power half. So completely the answer bases equal at the power here 1. 3 over 2, is it? Actually 3 over 2, this is completely 3 to the power 3. Let's simplify this 3 and root 3 is a check value once again. You put x4 3 root 3 plus 1 minus 1 cancel, and completely third root of 3 out, very important, third root, this is third root. Okay, so not 3 root 3, third root, okay, third root of square 3, not 3 times root 3, third root of 3. So you know that third root of 3 is 3 to the power 1/3, right? This is 3 to the power 1/3, so 3 cancel, that is 3 to the power, what is that, 3 to the power 1/3. So 3 cancel, that is half. That will, if I show 3 to the power 1/3 completely, 3/2. Okay, now see, this is cancel. What is pi by 4? Tan inverse 1, pi by 4, right? So what is that? 2/3 tan inverse, tan inverse. So that is a 3 to the power half square root 3. What is tan inverse square root 3? 60 degrees, or pi by 3, right? Pi by 3 minus pi by 4. So what is that? 60 degrees minus 45, that is 15, okay. Or that we call pi by 12, pi by 12, pi by 12, right? Therefore, interesting work. So pi by 12, okay. So see here 6 or 18 near my. So please subscribe and wait for more typical problem, superb future expectation of for any type of exam papers. Okay, we'll see you next time for the another international exam level expected for pure maths, applied maths, whatever it is. Okay, thank you so much for views my video series. Bye.